Intervals. Anytime a problem talks about ranges, time slots, meetings, segments on a line, one pattern handles almost all of it. Sort them, then sweep across once. Let's learn it, with no code, just pictures.
An interval is just a start and an end, a bar on a timeline. Two intervals overlap when one begins before the other ends. Scattered in a random order, overlaps are hard to spot. That messiness is the whole difficulty.
So here is the universal first move for almost every interval problem. Sort the intervals by their start time. Once they're in order, any intervals that overlap sit right next to each other. Now a single left-to-right sweep can see everything it needs by comparing each interval only to the one before it.
Reach for this pattern whenever you're asked to merge overlapping ranges, insert a new range, count how many overlap at once, or find free gaps between busy times. Almost all of them start the same way, sort by start, then sweep.
First problem, merge intervals. You're given a pile of ranges, some overlapping. Combine every group that touches into a single clean range, and return the merged list.
Sort by start, then walk through them, holding a current merged range. For each next interval, if it starts at or before the current range ends, they overlap, so stretch the current range's end to cover it. If it starts after, there's a gap, lock in the current range and start a fresh one. One pass folds all the overlaps together.
Next, insert an interval. You already have a sorted, non-overlapping list, and a new interval drops in. Slot it in so the list stays sorted and merged, absorbing anything it now overlaps.
Sweep once. Everything that ends before the new interval starts passes through untouched. Everything that overlaps the new interval gets swallowed. Expand the new interval to span them all. Then let the rest, which start after it ends, pass through. 3 clean phases, before, merge, after.
The boss, meeting rooms. Given a set of meetings with start and end times, what is the fewest rooms you need so that no two overlapping meetings share a room? This is really asking, at the busiest instant, how many meetings run at once?
Think of a sweep line moving across time. Every start adds 1 to a running count of active meetings. Every end subtracts 1. The peak that counter ever reaches is the answer, the maximum number overlapping at any moment. Sort the starts and ends, sweep through in time order, and track the high water mark. That peak is the minimum number of rooms.
That's the interval pattern. An interval is a range on a line. The magic is sorting by start so a single sweep can compare neighbors. Merge, insert, or count the busiest moment everyone was sort, then sweep. Once you see the timeline, these problems line right up.
That's pattern 13 of 18. Next, prefix sums, pre-compute once, then answer any range sum question instantly. Learn every pattern, plus hundreds more lessons. Master code. Master your future.
CodeSamur-ai